All right, so this is number 51 for the tangent line problems. And this problem says find the coordinates of all points on the graph of y equals 1 minus x squared at which the tangent line passes through the point 2, 0. So let me draw a picture of this for you so we get an idea of what we're looking at. The graph of y equals 1 minus x squared would look something like this. And the point 2, 0 is actually not on that line, sorry, on that parabola. So we're looking for a tangent line that passes through that point, but that point is not the point of tangency. So if I draw a picture of this, you can see there would definitely be a tangent line that does something like that, but there would also be another tangent line, this is going to be drawn kind of poorly, so I apologize, that would touch down here somewhere, because the graph would be going out like that. So what I'm going to do is I'm going to look at one of these tangent lines, this one, and I'm going to mark the point of tangency, which I don't know, with some sort of letter name. So let's give its x value a. So a is the x value of the point of tangency where that tangent line touches the actual parabola. And then its y value would be f of a. Okay? With me? Cool. Now, what I have here is a tangent line. And there are two ways of actually calculating the slope of a line, especially when you have 2 points on the line and it's a tangent line. So if I'm looking at this, I'm going to get the slope of the line 2 different ways. The first is I know 2 points that are actually on that line, 2, 0, and the point of tangency, a, f of a. So I'm going to use my good old delta y over delta x and find the difference between the y's, which would be f of a minus 0, and put that over the difference in the x's, which would be a minus 2. So f of a is what I get when I plug a into the function. So that would be 1 minus a squared over this a minus 2. So that's how you do it with the 2 points. However, this tangent line is also a tangent line. So the slope has to also be given by the derivative when you plug in a. So if I find the slope of the line through the fact that it's a tangent line, I would find the derivative of the original function. And then I would plug in a to get the actual slope at that point. So that would be negative 2a. Now listen, this line, although we found 2 separate ways of getting its slope, those slopes had better be the same because it's the same line. So if I take these 2 things and set them equal to each other, that gives me something entirely in terms of a that I can then solve. So if I cross multiply, and then if I get all the a stuff on the same side, and I get something that looks like this. Now I can look at this and tell it's not going to factor, so I'm going to jump straight into the quadratic formula. B squared minus 4ac all over 2a. So when I simplify that, that would be what? 4 plus or minus the square root of 12, which is 4 plus or minus 2 root 3 all over 2. So that's 2 plus or minus the square root of 3. Now, this is one of the coordinates of all the points on the graph, and I've gotten this a. There are 2 different a's here, 2 plus the square root of 3 and 2 minus the square root of 3. And those are the x coordinates of those points. So all I would need to do now is take those 2 things and plug them into the function to get the y values that correspond. So if I do f of 2 plus the square root of 3, that would be 1 minus that thing squared, which is kind of annoying, but not hard to do. 1 minus 4, let's see, that would be 2 root 3, 4 root 3, minus 4 root 3. And that would be minus 3. So I have, what, negative 6 minus 4 root 3? And then if I do 2 minus the square root of 3, that would be 1 minus 4. That would be negative 2 root 3, 4 root 3, but it's a plus because we're subtracting. would be minus 3. And that ends up being what? Negative 6 plus 4 root 3? So my points then are 2 plus the square root of 3, comma, negative 6 minus 4 root 3, and 2 minus the square root of 3. Oops, not writing that as a point. 2 minus the square root of 3, comma, negative 6 plus 4 root 3. Now, the numbers here are fairly ugly, but the process is actually pretty straightforward. And that's number 51.